Okay, so let's consider a universe, and in this universe we're going to have a few sets. So let this be a yellow universe, and consider two sets in this universe, A and B. And let's say that B is a set that has a bunch of elements. Let's say X, Y, Z, and T. And suppose A is a set whose elements are some of the elements of B, not all of them necessarily, but it does not have any other elements outside B. So let's say set A has two elements, X and Y, which also appear as elements in B. It's a very specific type of situation where we've got two sets, A and B, and one of these sets has all of its elements being also at the same time elements of the other set. So when something like this happens, we say that the first set is a subset of the second set, and we denote it like this. We write A and then the symbol, which is the subset symbol, and then B. So the double line here indicates that A could have been equal to B. So the only restriction, the condition defining this relationship of one set being a subset of the other set is that every element of A must be also an element of B. It is okay if A and B are equal, because then the requirement that every element of A is also an element of B is trivially fulfilled, so that's fine. But they don't have to be equal. Like in this example, they're not equal. B has extra elements that A doesn't have, so they're not equal. Now, formally, we can write down the requirement that defines when is A a subset of B, like this, by saying that for every x, x being an element of A implies x is an element of B. Let's squeeze in a bit here, lack of space. So this formula, maybe I should put tiny brackets in here to indicate the scope of the element symbol. So this formula expresses the fact that every element of A is also an element of B. Indeed, it says whatever x set you've got, if it turns out that x is in A, then it must also turn out that x is in B. And now we can actually check that this formula holds for this specific A and B in this example. Let's just add a few more sets outside B in the universe. And so now we have to run through all the small x's in the universe, and because small x represents a set, because variables always represent sets when we use the mathematical language for a universe of sets, so then the variables represent sets in the universe. So to now verify this formula, we have to run through all the possible values of small x, in other words, all possible sets in the universe, and check that every time it's in A, then it will also be in B. So let's begin with A. So if we take small x to be A, right, is it true that x being an element of A implies x being an element of B? Well, A is not an element of A. A only has two elements, x and y. None of them are A. So the premise in the implication is false. And as we know, then the false premise doesn't imply anything. So the implication is valid just because the premise is false. In other words, we could say that the statement that if A is an element of A, then A is an element of B is trivially true simply because A is not an element of A. Right? For the same reason, B not being an element of A, for X being equal to B, also this implication holds. And all the other dots here, which are not elements of A, for the same reason, that implication holds for them. And now the only two cases to be checked is when small x is either capital X or capital Y. And in both cases, they are elements of A. And then for the implication to be true, we need them also to be elements of B. And they are, because they lie within the region that encloses elements of B. So this video was about the subset relation. This is how we denote it. This is how symbolically we represent when one subset when one set is a subset of another set, and this is how this relationship is defined. For a set A to be a subset of a set B, this formula needs to hold. It's actually a definition, so A is a subset of B if and only if this formula holds. And then we also saw how we can check formulas like this by going through all possible values of small x and making sure that this implication is valid for all of them. Of course, the meaning of this formula, as we already said, is that it expresses the idea that all the contents of A, the entire contents of A, should be part of the contents of B. So pictorially, the region of a set A will be enclosed within the region for the set B when A is a subset of B.